Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and his brother Joel Chaiken. We're here to help you give some insights. That's the way to say it. Insights into how to approach SAT math questions. Here we have a sample question from a calculator section. I know I've never actually looked at this in my life yet. Seth, you may have already looked at it.
Well, before we came on.
Oh, yeah, I never. That's cheating. That's cheating.
Yeah.
Okay, I like to do things cold because that's the way.
All right, you do it cold.
Oh, let me see. Now I'm going to see if I can do it, which I'm sure hopefully at least I'll know how to approach it. In one semester, Doug and Laura spent a combined 250 hours in the tutoring lab. If Doug spent 40 more hours in the lab than Laura, how many hours did Laura spend in the lab? I feel very strongly about this type of problem. I go 2 equation, 2 unknown. I like methodical approach. 2 equation, 2 unknown. And D and L. And, you're not going to have time to say what D and L really mean, but D and L mean the number of hours in the lab, right? So D
for Doug
L,
and Laura.
Yeah, for Doug and Laura. D and L make 250. Now, this is where I get messed up. That's the easy one. Okay. With 2 equations, you need 2 unknowns. That's absolutely critical that you know. One unknown, I should have said it the other way. 1 unknown, 1 equation. 2 unknowns, 2 equations. So you need 2 equations. So we need now the second equation I always get messed up on. If Doug spent 40 more hours in lab than Laura, so you got to be really careful here. Wait a second. Doug equals 40 plus L. Now I checked myself. That means Doug's is bigger. So if Laura spent 10, Doug spent 50. Laura spent 10. I think I got it.
Okay.
So the standard way of solving this is substitution. You could use elimination, but substitution's the standard way of doing this. You just shove the D into this thing, and you get 40 plus L is equal to 250. 2L is equal, I'm cutting corners now, which I shouldn't do, but I'll do it anyway. 210, right? So L is 105. We subtracted 40 on both sides.
Very good.
And then,
So notice when you got the 2 equations and the 2 unknowns, you eliminated Doug because the question asked for the value of the hour number for Laura.
No, that was a coincidence, actually.
It's wise. I was looking at that. What should you eliminate? Well, you want to solve for L. Therefore, eliminate D.
Yeah, but Seth, I'm telling you, I didn't look at that when I did this.
I know. I realized that when you wrote the equations down.
Yeah, but there's an advantage to doing this but you're right. How many did Laura spend? Oh, yeah, so you got to be careful. You got to answer the right question. Frankly, this was a coincidence, but I went this way. Why? Because I didn't have to subtract. If I went with Laura, I would have had to do a subtraction. Anytime negative sign comes in an algebra, you make a mistake. You're right. If it was Doug, see what I would have done. If let's say they asked for Doug, I would have done it the exact same way. And then it's easy to go 105 plus X is equal to 250. Wait.
All right.
That's 155, right?
No, 55. I think I would have, if they asked for Doug, I would have eliminated L.
Really? And taken a chance with subtraction?
Yeah, sure.
Oh, okay.
Yeah.
Okay, I like to add things as much as possible as opposed to subtract anything. Negative signs are a danger.
Okay.
So what can be said?
All right. I have a geometric way of solving it.
Okay. I just want to make one quick comment. This question actually is usually taught in middle school, and they don't actually do 2 equations, 2 unknowns. They expect you to write this, but then immediately say D is 40 plus L. It's really, really dangerous when it's taught in middle school. The proper way to do it is to actually go 2 equations, 2 unknowns. That's the methodical way that is that really you should do. Okay, Seth. Anyway, so what's up?
Okay, well, here's what I thought. Do it geometrically.
So we should tell you something. We'll make you a nice, clean place, okay? Because everyone...
Nice, clean slate. All right.
Yeah, how about that?
All right.
I can't wait to see this.
Oh, yeah. And it turns out it'll be of course, the same arithmetic.
Okay, great. Go ahead.
So, here we go. We have... It says Doug spent 40 more hours in the lab than Laura did. So if you plot a rectangle that represents if you plot a rectangle that represents Doug's time,
Okay.
and then on top of it put a shorter rectangle that represents Laura's time.
Right.
Doug spent 40 more hours
All right. Yeah.
than Laura.
40. Yeah.
And then together, they spent 250.
Right.
Okay. So if you subtract the 40 from the 250, you get 210.
Right.
And so the time that they spent in the lab together, this whole time is 210 hours. Half of it was spent by Doug and half was spent by Laura. So the time spent by Laura is 210 divided by 2, which is 105. Same answer.
Wow, that's really cool. That's really, really cool. You could also make this a 2x, right? And then you could set 2x plus 40.
Yeah. So instead of using L,
yeah.
Instead of introducing a variable named L, I did the equivalent thing by introducing a sized rectangle. That one. And then I said that Doug's time is L, same as Laura's time, plus 40.
Right. Wow, that's a pretty cool way of doing it.
Yeah.
Wow. Wow. That's really cool. How long, since you looked at the problem ahead of time, how long did it take you to come up with that?
Well, I don't know, maybe 15, 20 seconds.
Good. Great. Yeah.
First, I first looked at the problem. I thought this is a standard one variable algebra problem.
Really?
Yeah. And then I thought, well, I could see a geometric significance, laying out the times. How would you solve it? How would you solve it by common sense?
Wow. Yeah. Wow. Yeah. That's really cool.
Yeah.
Great.
Yeah. Well, there's a sad story about kids who have good imaginations, and they're taught algebra. They go to the algebra class, and they're given problems like this, and they solve them using an imaginative reasoning method, and they get the right answer. And of course, their reasoning is valid. And then they get graded. They get downgraded and reprimanded by the teachers because they don't use algebra.
Yeah. You know what I would say is do it. Be a genius. Do it incredibly creative. Go ahead. Just come up with the brilliant way of doing it, but then check it using this way, because sometimes the brilliant method may not apply. You should know how to do it methodically, but use the methodic method to check to make sure your brilliant genius method actually works.
Yeah. But that's important. There's the other side of the argument is the argument supporting that is that it's important to actually learn algebra.
Yeah,
because algebra is a lot enormously more powerful than is enormously more complicated applications where it's very powerful.
Right.
Than applications as simple as this.
Right. Exactly.
So you have to learn the idea and how to apply algebra, so that as the problems that you face in the world, as they get more and more difficult, then you could use more and more of the power of algebra.
Right.
Yeah. So I think we knocked this one off.
Oh, yeah. I think we're done. Let's give everyone a break and finish in 10 minutes. Okay, everyone. So have a great day. Like us, dislike us, give us comments, and of course, send us any math questions you have, SAT math questions you have, at satmathquestionoftheday@gmail.com. Okay. I guess that's it, right? Yeah. Okay. Yeah. Okay. So we'll see you tomorrow. Tomorrow's Wednesday. Looking forward to Throwback Thursday. Looking for. Oh no.
Yeah. Wednesday. Yeah. See, Wednesday. Yeah, 11:00 is good.
Okay. Okay, everyone. See you. Have a good day.
Okay.
Wait, so we can talk about that off screen, about our personal schedules. Okay. Anyway, time to go. Okay, everyone. Have a great.